colors. Puneet, can you explain this question? Check this question actually.
Essentially, what they're saying is you are given objects and they're colored red in 3 different colors, and you need to sort them in place so that the same colors are with each other and there's a specific order given to specific color. Like you need to have first red color objects, then white color objects, and then blue color objects. And for simplicity, what they have done is given integers to each of the color, like 0 for red, 1 for white, and 2 for blue. And let's assume the numbers. So if you can see the input, you have 2, 0, and then 2, 0, 2, 1, 1, 0. And the output has to be something like 0, 0, 1, 1, and 2, 2. 0 representing the red color, 1 the white ones, and 2 the blue ones.
Seems like it's kind of a Dutch national flag approach question.
Yeah, it is Dutch national flag only.
Yeah.
Just a different way of saying for the same problem.
Yeah. But they are saying you need to come up with one pass algorithm using constant space.
And how much is the time complexity for Dutch?
I'm not sure.
Anyone has gone through Dutch national flag, could you just explain to everyone else, like for the benefit of everyone on the.
Yeah. Anyone has tried this question?
I believe like we just explained this question a while back.
Yeah, that's why we were discussing.
Yep, because this is the same as Dutch national flag.
Yeah, and I just wanted to ask that quick select approach would work best over here, correct?
Quick
Sorry,
select, like, yeah, go ahead.
Sorry, go ahead. Something.
Will quick select work here?
Yeah, my question is this.
What do you guys think?
Because it.
What does quick select do? That's
Yeah,
the main.
That approach which we were discussing last.
I believe a quick select is a different approach where we are trying to partition the array based on the pivot. Okay, so the elements on the left are lower, elements on the right are higher than the pivot. But here we are trying to do the similar thing, but instead of pivot, it can be a range. So yeah, so you need to have like 0, 0, and then 1, 1, 1, 1, and then 2s. So I'm not sure like quick select will work here.
Actually, quick select can also work here, but it will not be as efficient as Dutch national flag. Can someone kind of guess how we can implement a quick select and get this thing? Sorting of 3 colors, but using quick select. It may not be optimal, that's fine, but just to relate quick select to this problem.
I have one question. So they are sorting them on the basis of the frequency, not on the basis of the number 0, 1, 2, correct?
We are sorting them based on the color.
Like frequency of the color or the.
No, there's no frequency, it's just colors. The same colors should be along each side. And the first color that should be in the array should be red one, which is 0. Second is white, which is 1. And third is blue.
Okay. Whatever the, like for example, 0 is 4 and 1 is 2, it doesn't matter.
Yeah,
it doesn't matter. You can have like the red color, like the first color, whatever is representing 8. Second can be 2. Third can be, let's say, 9. Okay, so your result can be 8, 2, and 9 in order.
Okay.
Yeah.
Okay. So anyone wants to discuss the approach?
I have one idea. I think this is similar, like to me, like the moving all the zeros at one end, and then what is the next color we move that color to the other end. So there is a standard problem, like move all the zeros to left or right. If I can try that, I can move one color on left side and the other color on the right side.
So can you try this on the current input set? Just try it out.
Sorry, I couldn't get you.
So could you simulate your algorithm on the input that you can see like 2, 0?
So just trying to understand, like you guys told like it could be different numbers also for the colors.
Yeah, it can be any color, any three numbers. Like it can be 3, 4, 5.
But what order we have to select in the
So let's assume the smallest one is the first, then the next
okay.
higher, and
So it could be any three numbers. The smallest would be on the left.
yeah, let's assume that way.
Okay, let me
So
try
what should,
to.
what should be the brute force approach?
Brute force is like sort them, I think.
No, like question doesn't say that. Okay, let's say I have a number 8 representing some color, then 2 representing some color, and then 9 representing some color, and I want like all the 8s to be first.
Mm-hmm.
Okay, I'm not sorting them. 2 can come after 8s. What I need all the 8s to be in first place, all the 2s to be in the middle, and all the 9s to be in the last. Okay, so it's like not necessarily the sorted array.
Yeah, but then they have to mention like what order it should be.
Yep. So take my example. Okay, like how you will bring all the 8s in the first, all the 2s in the middle, and all the 9s in the last. You cannot like sort the array.
Yes. So in that case, they will also tell the order. So we're doing one more level of complexity here.
Yep.
Because in this question, it is not mentioned. I think so.
So just like what the brute force approach? Can't we just like move like pick the first number which need to become first, iterate through the array, and then bring it to the start. Okay. While we are done with the first pass, okay, all the numbers, let's say zeros in this case, are at the start, and then 2s and 1s are like maybe in some random order. Okay.
But you're also telling take an extra array first.
No, like not take an extra array. Iterate through the same array. Okay. As soon as we find 0, have 2 pointer approach. Okay. Have a start index and then the next index, like which will keep like moving forward. Okay. As soon as you find a 0, replace it with the start index and jump the start index by 1. Okay. So by the first pass, once we are done with the array, what we will have all the zeros in the first place. Okay. And then 2s and 1s, they might be in any order. Okay. And we also know at what index we wrote the last 0. Correct? Okay. Then from that index, we can again repeat the same process, bring all the 1s to the first and then 2s to the end. It's a 2-pass solution.
I just want to ask, you are saying it's for like in the first pass, we'll take one index. And if we are taking that, if we are replacing, for example, here 2 with the 0, then this count of 2 will get replaced.
No, like, so you have, let's say you have 2 and 0. Second element is 0. Swap them. Okay. Okay.
So I think it's the same like what I was mentioning, like moving first, like the problem, like where we want to move all the zeros either to left or right.
Yep.
Yeah, got it.
Yeah, so we can do it in like 2 pass.
But that because we know we'll be having one element at the end, so we are just considering all the elements moving further. But here is like if we are taking that particular problem, here we need the swap logic as well. I think the other
We
question we were
no,
doing,
I think we don't need a swap logic. What Gaurav is mentioning, like we know what needs to be on the other side. So keep on moving things, and then just overwrite whatever is at the end with what you need.
How can we like last time you shared the screen with a whiteboard? How to do that?
You
uh,
click share and then click. Oh, so somebody has to stop sharing.
I
Okay.
have stopped sharing, and you need to go to the share option, and there is a white board as well.
Okay. Now I
Yeah,
found. Can you guys see it now?
yeah.
So our array is 2, 0, 2, 1, 1, 0. Correct?
Mm-hmm.
Our start pointer will start from here, and then like we have 2 pointer I and j, let's say. Okay. Then move the second pointer at this position. If we find a 0, swap them. So it will be 0, 2, 2, 1, 1, 0. Okay. Now our then jump, like after swapping, move the start pointer one ahead. So our start pointer is now here, and then the I and then the j is here. Then move j like one by one location. Okay, here it's not a 0. Move again, it's not a 0. Move again, it's not a 0. Move here, it's a 0. Swap this number and then this number. So it will be 0, 0, 2, 1, 1, 2. Correct?
Mm-hmm.
And by this time our start index is here, the I, pointer I. Okay, so we brought all the zeros to the start. Correct? Now repeat the same process on this array. Initialize the I from here and j at the same location. Okay, and then repeat. So in this case, when we move the j, okay, we find a 1, so we will swap 0, 0, 1, 2, 1, 2. We will move the I and j is already here. Then move j one index. Okay, we again find 1, swap them 0, 0, 1, 1, 2, 2. Okay, keep going. We reach the end. We are good. So in the 2 pass, all the numbers are sorted or like moved to the location that we wanted.
Yeah, that sounds one approach to me. Yeah. And this can be done in one pass.
Yep, this can also be done in 1 pass. So this is a 2 pass solution.
Mm-hmm.
What's the time complexity of this one?
Order of n only.
Order
No,
of n for the first pass,
first
and then
pass, yeah, more than.
order of n for the second pass. So total is order of n.
Yeah.
Okay, and then can someone explain how we can do it like in 1 pass?
If you add one more pointer, maybe you can do it with 1 pass. Yeah,
Correct.
yeah. One pointer point to the first color and another point to the last color. Yeah, when you iterate the whole array, if you see the 2, you swapped with the last color. If you see the 0, you swap with the first color. If you see 1, you keep it stay.
Do you want to explain?
Okay, yeah. Whiteboard.
I believe like we are over time like 5 minutes, but I guess it should be okay for you guys.
Okay.
Don't worry, it's a normal thing for us. Like we usually go up by 15 minutes.
Okay.
Yeah, I have the example is 202110. Okay. Like the example is 202110. I have 2 pointers. One point is like the first. The last, another point is point to the last color, so maybe L. And we iterate the whole array from the start. It's I, iterate the whole array. If the I equals last color 2, we swapped 2 and this one. That means this is a 0, 0, 2, 1, 1, 2. And this is, and the L move backward one step. And this time I point to the second element here. And it points to the 0. 0 is the first color, so we swap towards with this one. 1, 0, 0, 2, 1, 1, 2. And the first color point to this position. This is the first color. And at this time, I move to the 2, and we see the 2 is swapped with the last color. So we get the 0, 0, 1, 1, 2, 2. And I move to this one. When we see the middle color, we didn't do the swap, and we keep the I moving forward, and we didn't swap here because it's already equals the last color. Yeah, I can show my code. Maybe it's more easier to understand how to implement the one pass.
Sure.
This solution is great. This is what is called like Dutch national flag sorting.
I didn't know that name. I just use a pointer. Yeah. If we, I remember I solved a similar question like a requirement to do the one pass sort and with constant space. So you can't create a new array to store your sort results. So I usually use the pointer to swap them. Okay, I'll show my stop sharing. Yeah, yeah. This is my code. I have the 2 pointer. One is point to the 0 position, and one pointer named 2 point to the last of the array. So in this for loop, we keep I moving forward, and if the num I equals 2, that means this is the last color. We swapped the current num and the last color, and we move the last color -1 here. And if the nums I equals the first color, we swapped with the 0 point, and keep the 0 point move forward by 1. Oh, Sorry. Have any question? Hello?
I will try myself and try this thing. But yeah, this is a good one.
I just have, that one question again for everyone. How can we apply quick select to solve this problem?
Select sort. As we
Quick select algorithm.
Yeah, as we discussed before, the 0, 1, 2 is represent 3 color. Maybe the 3 color is not in increasing order. Maybe the red, white, blue is like red is 1, white is 0, blue is 2. So in that case, we cannot use the select sort or quick sort to solve them by the value of the element. And another thing is if we use the select sort or quick sort, the time complexity is only n log n. So,
I'm not just saying, I'm not talking about the best case scenario of best algorithm. I was just trying to see how we can relate a quick select algorithm to this one.
What I believe like quick select is like not going to work here because quick select is not a sorting algorithm. Quick select will give you the max n numbers, k numbers, or like min k numbers in order of n in the average case, n square in the worst case. I don't think like you can sort it based on the quick select.
But we only have 3 values here. So if we can just take, like, suppose, let's say 1 as a pivot element, get all the zeros on left hand side, 1s and 2s on right hand side. Now
Okay.
our problem reduces to right hand side section and just take pivot as 2. I hope that is clear or not. I can check my screen. So suppose you have
I'm not very sure.
let's take our pivot element is 1. Right? So for sure we can have all the elements 0, 0, 0 before that we are sure, right? And we can have some set of numbers here. It can be 2, 1, 1, 2, anything, right? So we have sorted one set of, we have moved one set of numbers to left hand side. Now problem reduces to quick select on this set of problem with pivot as 2. And then we'll have 1, 1, 1, and then 2. So sorting this one by one. I'm not saying it's a classical algorithm with very good time complexity, but just how we can relate quick select to getting this problem solved. Is it still confusing? Hey guys, am I audible?
In this case, like 0, anything which is, so you'll consider like 0 is also smaller than 0. So anything that will come to left side, other things will go to right. Then you'll take 1. Anything
Yeah, pivot
like
here is 1. 1 is a pivot element.
Mm-hmm.
So anything which is less than that will go in the left section. Right? That's what pivot, the quick select does. It will take the pivot.
Yeah, but if you're taking 1 as a pivot, still there's no guarantee 0 and 1s could be mixed up.
Yep, because what if you select the pivot as the second last element?
No, I'm saying to select one because we know if we have 0, 1, and 2. Let's not say 0, 1, and 2. Let's say black, blue, and white. Right? If I select the first one, I need to get zeros, or suppose reds on the left hand side. What is the next element there? Suppose it's white. So I'll select white and push all the blacks to the left. And then I'll select blue, which is my last element. And then and my problem is only this much now. I have solved for this one. So this one I'll not consider index as I2. I plus
in either way, this is as good as what we just discussed, like Gaurav.
It's same as that one. I'm just saying how we can relate it to quick select.
See, so the other approach which we discussed in quick select, they're both 2-pointer approach. So they will share the traits, obviously.
Right.
Like in a 2-pointer, it's how it depends how we play with the 2-pointers. So definitely I see like quick select, anybody who wants to try with the not familiar with 2-pointer and want to brush up how exactly that works. Quick select is a really classic example how 2-pointers work. That's what I feel. So if somebody does not aware about how to play 2-pointer, get it started with quick sort only. That's what I advise. And then it can be applied to other examples like moving zeros to left or right, or this example problem we just discussed.
I think we are about time for today.
Yeah, seems like anybody wants to discuss anything? I'll stop recording.